In today's video, we will be covering the concepts of differentiation, integration, and their applications in real-life context. Differentiation is the instantaneous rate of change of a function with respect to one of its variables. We will share with you two scenarios for further explanation. For the first scenario, if we are given 2 points on the tangent line, we are able to find the gradient. Gradient formula is given by the change in y over the change in x. Given the value of point A and B, we are able to calculate the gradient, which in this case equals to 4. For the second scenario, if we are given a function and a point on the graph, we are still able to find the gradient. If the given function is y equals to x squared minus 2x plus 1, by differentiating the function, we get 2x minus 2. Given the point x equals to 3 and y equals to 4, the gradient will still be 4. For example, a disk expands during heating, and the surface area is increasing at a rate of 2 cm per second. So how fast is the radius changing when the circumference is 10 cm? We are asked to find the rate of change of radius with respect to time. The change of radius over the change of time will give you dr over dt. So using chain rule, we can derive that dA over dt equals to dA over dr times dr over dt. It is given in the question that dA over dt is equals to 2 cm per second. To find out what dA over dr is, we differentiate the area of circle with respect to its radius, which in this case dA over dr gives us 2 pi r. By subbing the values found previously, we know that dr over dt is 2 over 2 pi r. When the circumference of the circle is 10 cm, the radius of the circle will be 5 over pi. By subbing the value of r, we can conclude that the radius of the disk changes at the rate of 1 over 10 cm per second. Integration is the process of finding an indefinite integral, and it is the reverse of differentiation. The differentiation of a displacement gives us velocity, and differentiation of velocity gives us acceleration. Thus, the integration of acceleration gives us velocity, and the integration of velocity gives us displacement. For example, the velocity of a car at t seconds after leaving point O is given by v equals to 4 minus t squared. Find the acceleration of the car after 4 seconds and the displacement of point P from point O when the car is instantaneously at rest. So to find acceleration, we will differentiate velocity. The differentiation of velocity gives you negative 2t. So when t equals to 4, acceleration will be negative 8 meters per second square after 4 seconds. The displacement of point P from point O is the integration of velocity, which is 4t minus 1/3 t cubed plus c. So when t equals to 0 and s equals to 0, c will be 0 too. When p is instantaneously at rest, velocity equals to 0. Therefore, t equals to 2, and we can conclude that the displacement is 5 over 1/3 meter.